Hello and welcome to the first lab of Physics 2 titled Charge Tapes. In this lab we're going to be taking a look at electric forces and trying to model an electric force between two pieces of negatively charged tape. We're going to be floating one tape above another and looking at repelling forces. So when the charges are the same, you're going to be able to push one away from the other. So we're going to write a computer model to calculate and visualize the electric force necessary to counteract gravity and do some other calculations. And of course the main purpose of this lab is to learn how objects can become charged, how they interact with other charged or neutral objects, and be able to do some calculations, particularly calculating charge based on the electric force given. So the main physics principle we're going to be using in this lab is the electric force law, where you have the force, the electric force is equal to the Coulomb constant times the two charges times the position vector divided by the magnitude squared for the position vector. We're going to use 99 for the Coulomb constant, and we're going to be treating both pieces of tape as point charges with equal charge. We say equal because they're pretty much the same size and are treated the same, so we can do that, and that makes this calculation a little simpler with having just the one variable q squared. And we're also going to be revisiting the momentum principle and law of universal gravitation for calculating our force of gravity in our computer model. So in this lab we needed to create two pieces of charged tape, and so we were following these steps here in order to accomplish that. I'm not going to read through them all for the sake of time, but of course noticing that each charged piece of tape is going to be attracted to neutral objects like your hand, and it's also going to be attracted to opposite charged objects, but of course repelled by the same charge objects. And this is kind of the second half of what we did in the experiment. This here is the data that we collected in our experiment, which of course we'll be using in calculations with our computer model. These are measured in centimeters here. We're going to convert those units to meters when we're actually doing the calculations. We're only going to be taking the floating tape to be our system, and the only forces acting on this system are gravity and the electric force from tape A. So you're just going to have two arrows pointing in opposite directions and the point charge. And both forces, of course, are working in the y direction. Now, if we take a look at our code, we see we have the constants where we have the Coulomb constant, the charge of an electron, like the scale factor that we'll be using for visualizations. We have the measurements for the tapes, including the mass, which we'll need to calculate the gravity using the y-hat vector. Of course, it's pointing downward, and so the electric force will be pointing upward. It will be the opposite direction of gravity. It will be equal and opposite to the direction of gravity, since those are the only two forces acting, and then F net, of course, is set to 0. And then we can calculate the charge of our system based on Coulomb's law. So we'll take the magnitude of the electric force, we'll divide it by Coulomb's constant, and then multiply it by the distance between one charge and the other squared, and then we'll take that square root of the entire thing, of course making it negative because we remember the charge is negative in this case. We have our arrows and then some other calculations, and when we run it, we see the two arrows in the point charge, the green arrow representing the gravitational force, the orange arrow representing the electric force. We see that value-wise they're equal and opposite to one another in newtons, and the charge from each of the tapes is equal to this amount in coulombs. And now we have these questions left to answer. What if electrons had a positive charge and protons had a negative charge? The answer is that it would not really have a consequence. These interactions would not change at the end of the day. It just matters that opposites attract and same charges will repel. So whether it's both positive or both negative, it won't really change. As long as everything's flipped, it should be the same. And why is it important to handle the charged tapes minimally, touching them as the least amount possible? It's because the more that the tape comes into contact with other items, the more likely and the more chance it is for those electrons to leave the atoms of the tape and become transferred into another object, and that's going to reduce the charge of the tape. So from this lab we can conclude that using Coulomb's law, we are able to calculate a point charge given the magnitude of the electric force acting on it, the source charge, and the distance from the source charge. If we have those three things, we're able to calculate the charge. And based on interactions that we can observe between objects for which we know the charge and objects for which we don't, we are able to deduce based on those interactions the sign for the charges that we don't know.